Okay, we're going to do a quick review over set 48. That was our complex fractions, simplifying our complex fractions. Didn't do so hot on those in our test. So hopefully this quick little review at the beginning will help you guys. Well, first off, if we remember, our main goal is I need to have a single fraction over a single fraction. If I have a single fraction over a single fraction, let's say I have 1/2 over 1/3, okay, I can simplify that by saying that this is 1/2 divided by 1/3. And if I have 1/2 divided by 1/3, I really know that's 1/2 multiplied by the reciprocal. So we're going to use that exact same principle to simplify with these. So I need to have a single fraction on top and a single fraction on the bottom. So if I'm looking at this first one, do I have a single fraction on top? No, I have two fractions. So my first step needs to be to add these two fractions together, or subtract in this case, because we have a subtraction sign. So if I look, can I write a +1 and a +1 to make that a common denominator? No, you cannot. If I was trying to add 1/2 plus 1/3, okay, when you guys were younger, you couldn't go +1 +1 to make that work. They were not equivalent fractions. The same thing is true here. We need to have common factors. So if I am looking at this, x plus 1 is a factor, and x is a factor. So that means that this denominator here only has a factor of x plus 1. It does not have a factor of x. I need to multiply so that I have a factor of x on the bottom. If I do something to the bottom, the same thing has to happen to the top. Now on my left side here, it has just a factor of x. That means that it needs to have a factor of x plus 1 with it. If I do something on the bottom, I must do the same to the top as well. So once I do that, I now have a 2 times x plus 1 minus a 1 times x. And those are all over x times x plus 1. Okay? So I've got a 2 times x plus 1 minus a 1 times x. And since their denominators are the same, we can write that over one denominator. Okay? I keep simplifying. I would need to distribute my 2. That would give me a 2x plus 2 minus x. And then simplify, that is over x times x plus 1. Then I want to simplify one more time. I end up with x plus 2 over x times x plus 1. Now, when you guys are doing these on your test, a couple things that you guys are doing wrong. When you're writing an x times x plus 1, a lot of you guys are distributing that in. That's not necessarily wrong, but it's too early to do that. You need to leave your x times x plus 1 separate so that you can see if you can cancel later on. Okay? Another mistake is, I think you guys are forgetting that as we are adding these two fractions together, okay, I'm adding these two fractions together here. This is still part of a larger fraction. So my 2 times x plus 1 minus 1 times x over x times x plus 1 is not by itself. It is still over a 3 over x. This right here is still over a 3 over x. And this right here is still over a 3 over x. Okay? We have to include that as we're moving along. Once I get to this step here, I can see I now have a single fraction divided by a single fraction. So once I get it so that I've got a single fraction divided by a single fraction, now I'm ready to change this using my multiplication. I'm going to have an x plus 2 over x times x plus 1. And then instead of doing division, I am going to multiply by the reciprocal of the bottom. So the reciprocal of the bottom is x over 3. Now, again, I told you guys you did not want to distribute on the bottom. I want to leave this as an x times an x plus 1. Why do I want to leave that there? For this step, I've got an x in the top right, and I can cancel that with this x in the bottom left. We can cancel diagonally. So I end up with, on top, just an x plus 2 over a 3 times x plus 1. And that's your answer. If you want to take it one step further, you can do x plus 2 over 3x plus 3. Either of these two answers would be correct. Okay, either one would be right. I don't care which one you have. Okay, now that you've finished up the first one, I want you guys to take a second and do the next two with the people at your group. Okay, after you guys finish the next two, we're going to pull up the video and you guys can check to see if you are correct. Okay, but I need you guys to do the second two. Do the second two on your own, working at your tables. Talk to each other. Okay, help each other out with these problems. Once you guys finish up with those, then we will watch the video and you guys can make sure that you did them correctly. Okay, hopefully you guys have watched how to do, or hopefully you guys have tried these on your own. So now just quick check your answer. I've got a x over y plus a 1 over x plus 1. This side here needs a y. This side here needs an x plus 1. Okay. I've got on top then an x squared plus x plus y over a y times x plus 1. Okay. Just kind of real quick, I skipped some steps there. We had an x times x plus 1 plus y, or 1 times y. Okay, distribute that in. X squared plus x, 1 times y gives me just a y. That's the part that goes on top. Remember, leave your denominator completely factored. Leave your denominator factored. Okay, so I've got my top part there, x squared plus x plus y, and that is over 3 over y. I do have a single fraction on top and a single fraction on the bottom, so I'm ready to set this up then. I'm going to take x squared plus x plus y over y times x plus 1, and I'm going to multiply that by the reciprocal. Okay, again, I can cancel these variables here, so I am left with an x squared plus x plus y over 3 times x plus 1. Okay, for your final answer, if you want to, you can distribute the 3 in. You do not need to. Okay, this is your final answer. You could also on the bottom have a 3x plus 3. Okay, that would work as well. Okay, and then again, I hope you guys have tried to do these on your own. Okay, final example here. I've got a 1 over x over an x plus y over 1 over x. Okay, on this one here, there is a single fraction on the top. There is not on the bottom. So I need to get these to be, to have common denominators. So one has a denominator of a y, one has a denominator of an x. That means the one that has an x is going to need a y. The one that has a y is going to need an x. So I end up with x squared plus y over, both of my denominators are simply xy. So I've got an x squared plus y over xy. And then that is on the bottom. Okay, this is like the one on our test, and a lot of us made a mistake. That's a 1 over x over an x squared plus y over xy. So when I do this, the top fraction stays how it is. It's still a 1 over x, and we multiply by the reciprocal of the bottom. I multiply by the reciprocal of the bottom. Okay, my x's cancel. When my x's cancel, I end up with just a y on top over an x squared plus y. Can I cancel my y's there? No. That y is part of a term. You cannot cancel a term. You can only cancel factors. Okay, so my final answer on this is y over x squared plus y.